at this. First thing that we are going to look at is something called the modulus function. Now, all the modulus function does is give us the size of a number. Okay. Now, what does that mean? So, for example, if we have size of 3, that is 3. If we have the size of -3, well, that is still the length. Essentially, what it's saying is the length is 3. So what ends up happening is anything negative, it ends up giving us a positive value for. Okay, so for example, modulus of -5 is simply 5. Modulus of -a is a. Okay, so you might be wondering, well, how's this relevant? We're going to look at that now. Just remember that it essentially turns everything positive, turns values positive. So let's have a look at something. Y equals x minus 3. We can sketch that relatively easily on a pair of axes. You have got something that looks like this. This is -3, this is x, this is y. What's the x-intercept, please? What is the x-intercept? For this curve? Shouldn't be too bad. My y equals 0, so 0 is going to equal x minus 3, so I get x equals 3. So that point there is 3. Now, if I now look at y equals the modulus of x minus 3, so now we're looking at the modulus of a straight line. Well, what we understand is all of these values here are negative y values. So if they're negative y values, what I need to do is turn them positive. I just want the size of those y values. So what's going to end up happening is I am going to get the positive bit remains as it was. And this is 3. Anything that was below the x-axis now gets reflected into it, and we get something that looks like this. What previously the y-intercept was -3, now that has become 3. Now, the most important part of this is to label the equation of the graph appropriately. So the unchanged bit, i.e. the positive bit, is still x minus 3. The equation of that line is still x minus 3. What is the downward sloping line? I multiply this by -1, and we get -x minus positive 3. Okay, so just remember that this is crucial, especially when it comes to solving equations on graphs and things. Okay, does that make sense on how the modulus function works on graphs? Right, okay. So I want you to have a go at this. I want you to sketch it, and I'm going to put a thing in the Google Classrooms for you to send me your sketch, please. Firstly, what you want to do is start off with your base graph and then do the transformations. You don't want to do them all sort of all in one go. Okay, so my starting point would be to start off with 7 minus 5x, and maybe I'll write that as minus 5x plus 7. So that then tells me I've got a downward sloping graph, goes through 7. This point here is going to become 7 over 5. I'll be happy with that. Does that make sense? The next step that we are going to do is look at the modulus of 7 minus 5x. And so anything that was previously had negative y values is now going to turn positive, so ends up looking like that. This point is still 7 over 5. This point is still 7. The equation of the original part of the line is still 7 minus 5x. The equation of the red part of the line becomes 5x minus 7. I still need to do one more transformation. It was 7 minus 5x plus 3. So if I think about that, everything is going to shift up by 3. So I shift everything up by 3. Oops, that's so bad. I'm going to get something that looks like this. My y-intercept here is now going to become 10. This minimum y-coordinate is 3. X-coordinate remains at 7 over 5. The equation of this part of the line has become 10 minus 5x, and the equation of this part of the line has become 5x minus 4. Okay, does that make sense? Are you happy with the thought process required to sketch a graph like this? Okay, don't do it in one go. Take your time. You're going to drop easy marks on here if you do that, please. Right, okay, so we've drawn that, and that, to be fair, is fine. Now, f of 1, how would I work this out? You didn't need to sketch the graph to work this out. Essentially, we are going to do 7 minus 5 times by 1, modulus of all of that plus 3. So in this case, we get modulus of 2 plus 3, and we get, the size of 2 is 2, plus 3 is 5. That's f of 1, that's part A done. Can you please have a go at part B and tell me what you get? If I now do f of 10, I'm going to do 7, modulus of 7 minus 5 times by, oops, no, I've got a bracket there, minus 5 times by 10 plus 3. So I've got modulus of minus 43 plus 3, and the size of minus 43 is 43, plus 3 is going to be 46. Okay, so that's good. And so what's C going to become? F of minus 6 is going to become modulus of 7 minus 5 times by minus 6 plus 3. You get modulus of minus times the minus is plus, so 37. Oops. And then plus 3, and we get 40 there. Okay, does that make sense? Any questions there? Right. Here's the next question I'd like you to have a go at, please. That is where you're all sort of going to drop marks, I feel, if you are not careful. So, again, starting off with this, we have something that looks like this. Here's 4, and this then becomes 8/3. But this bit here is negative, so we are going to reflect that. In fact, I'm going to do it here. And so we get something that looks like this. Now, this is still 8/3. This is still 4. The original part of the line still has the same equation, 4 minus 3/2x. The right-hand side part is going to become 3/2x minus 4. Okay, please be aware of that. And then finally, we are going to have the horizontal line at y = 5, something that looks like this. And so we can see that there are 2 solutions, one over here and one over here. That's where the equation of the line makes it really easy for you to work out, hence solve that equation. So the first equation, we are going to do 4 minus 3/2x = 5. We get minus 3/2x = 1. And so x equals minus 2/3. And the second equation that we are going to solve is 3/2x minus 4 = 5. 3/2x = 9. And so x equals 6 here, which makes sense. This is 6, and this is minus 2/3. Does that make sense? So we've been asked to sketch on the same diagram. So I'm going to start off with minus 2x. That's nice and simple. One thing I want you to pay attention to is the gradient. We've got m equals minus 2 and we've got m equals 1/2. Which one is steeper, please? Which one is steeper? Looking at the gradients of these 2 lines, because one gradient is minus 2, one gradient is 1/2, the steepness is looking at just the size of the number. So minus 2 actually is steeper. So how's this going to have an impact on the way I draw it? I'm going to draw minus 2 very steep like this. And then when I draw the 1/2x graph, I'm not going to draw it as steeply. So you're going to see what I mean by that now. So 1/2x minus 2 is going to look something like this and this. And so we have, oops, a 1/2x minus 2 here, minus a 1/2x plus 2 here. The y-intercept is going to become 2. This point here, if I make y equal to 0, I get 4. And you can see that I've taken the steepness of the 2 lines into consideration. That's what I meant when I gave you your feedback on your diagrams. Does this make sense? Can you please let me know in the chat? Do you understand what I mean when I say steepness? Right, okay, so now looking at this, it says B, solve that equation. How many solutions can we see on this graph here? How many solutions are there to where minus 2x equals the modulus of a half x minus 1? There's only one solution, and we can figure out what that solution is by making minus 2x equal to only this part of the equation of the line. So then I'm going to make that equal to a half x plus 2. And I get 5 over 2x equals 2. So x is going to equal 4 over 5. No, I've done this wrong. I've done this wrong. I've added it incorrectly. Oops, sorry. So I get minus 3 over 2x equals 2. If I take that over, and then I get x equals 4 over minus 4 over 3. I made the same mistake as you had. And all it wanted was solve that equation. Didn't want the coordinates. Sometimes it wants the coordinates when it only wants the x value. So now what we have realized is that the x value there is minus 4 over 3. And that I made by making only the minus 2x graph equal to that part of the graph there. Does that make sense? Can you please let me know in the chat? Okay. So the key thing, another key thing you've learned is take steepness into consideration. Take steepness of two lines. If you draw them parallel to each other, you won't see any intersections, and that won't be right. Then according to that, there will be no solutions, and that's definitely not the case here. So we can see here that x equals minus 4 over 3. Right, okay. Here is the next question I'd like you to have a go at, please. So we've got two equations. Essentially, when it says solve that equation, what you should be thinking is y equals modulus of 3x minus 5, sketch that, and y equals 11 minus x. That's what we are trying to do. So we think about which one is steeper. Obviously 3 is steeper. 3x minus 5 is going to look something like this. And then you might have something that sort of goes up there. Your y-intercept there is 5. This is going to become 5 over 3. Okay, and then we think about 11 minus x. Now, downward sloping line, y-intercepts up here somewhere. I've not drawn this diagram very well. Actually, I'm going to delete this, start again. So if I think about 11 minus x, there's something that looks like this. This point here is 11. Okay, and this point here is also 11. Now, if we think about 3x minus 5, that still stands. So I'm going to have something that looks like a steep line. much steeper. This is 3x minus 5. This is minus 3x plus 5. Y-intercept here was 5. What we see here is that there are two solutions, and we can figure out what they are by making each part of the line equal to the modulus function there. So this was 11 minus x. So x1, for x1 we are going to do 11 minus x equals minus 3x plus 5. For x2 we are going to do 11 minus x equals 3x minus 5. Does that make sense? In this case, you had to again take the steepness of each curve into account. So we've got 4x equals minus 6. And so x equals minus 3 over 2. Or we've got 4x equals 16. And we get x equals 4. Does that make sense? So we've now got an inequality, but the principle is still the same. We need to sketch 2x plus 9, a modulus of 2x plus 9 and 14 minus x. So let's have a look. Ideally, nice big diagram so we can get everything on there. 2x plus 9 is going to go through the y-axis at positive 9, upward sloping diagram. In fact, I'm going to start again. I'm just going to make sure I compare 2x with 1x, because the gradient here, essentially, I just look at the size of the number to figure out which one is going to be steeper. Very important. 2 is going to be steeper than 1. I just look at the size. So I'm going to get something that looks like this and this, okay? And of course I want my y-intercept. This is 9 and this is 9 over 2. Minus 9 over 2, I should say. And then we have got 14 minus x. Now, my diagram is not the best, but you're going to see the understanding of this diagram. Right, I'm going to have something, no, this is what I mean. Right, okay. Maybe I'll have it like this, and I myself. I've got something that looks like this. Okay, and what do we have here? We've got our y-intercept is 14 there, and this is 14 minus x. This was 2x plus 9. This was minus 2x minus 9. Now the question is saying that the modulus of 2x plus 9 is less than 14 minus x. So that means we are looking at where the y values for this are less than y values for this. Well, that means here all the way up to this point here. Does that shaded region make sense? Can you please let me know in the chat? And so I need to work out the two solutions first. So we're looking at minus 2x minus 9 equals 14 minus x. Hopefully I won't mess this up. Got x equals minus 23. So what that tells me is that this x coordinate here is minus 23. And then for this solution here, I'm going to say 2x plus 9 equals 14 minus x, 3x equals 5, and x equals 5 over 3. So this solution here is 5 over 3. So what is my solution looking at the graph? Can you please, looking at the graph, tell me what the solution to this should be? Right, yeah, that's good. The answers coming in are good. I want answers from everyone who hasn't answered. What is the range of values? You look at that and you think, okay, between minus 23 and 5 over 3. So we are going to write that as one inequality and say that it lies between minus 23 and 5 over 3. Does that make sense? Are we happy with that?